Hello, welcome to this lesson. In this video, I'm going to solve this question I have on the screen. So the question says we should find the current in the 10 ohms resistor using Norton's theorem. So let's look at how you are going to solve this question. So to solve this question, the first thing you have to do is to take out the 10 ohms resistor, okay, which is this 10 ohms resistor here, and then short circuit the terminals, which is terminal A and B. Okay, so when you do this, you're not going to have the resistor there anymore. So when you look at this second circuit here, you see that you don't have the 10 ohms resistor there, but you have short circuited its terminals, and then you have named the current going through the the Y there as IN, which is Norton's current. So our main goal here will be to find the short circuit current, which is Norton's current, and then from there we find Norton's resistance, then we draw Norton's equivalent circuit to find the current flowing through the 10 ohms resistor. So let's look at how you are going to solve this question. Okay, so one thing about this question is that we have just a single current source. Okay, we don't have, as in the other cases where we're having two voltage sources or one voltage source and one current source. Okay, in this case we have just a single current source. So let's look at what will happen in this circuit. So when we take out the 10 ohms and then short circuit the terminals, what will happen is that this 24 amperes, okay, that is coming from the source, when it gets to this node, it will split into two, okay, with some flowing through the 6 ohms and then some flowing through the 3 ohms. Okay, so what will happen is that when the current that is flowing through the 6 ohms gets to this uh, node here, what will happen is that there is a resistor here, which is the 9 ohms resistor, and then there is no resistor in this branch, so the current will not flow through the 9 ohms resistor branch. Okay, it will flow in this direction, then back to the circuit. So then you see that the 9 ohms resistor there will be short circuited. So now let's find the value of what Norton's current. So what will happen is that if I'm to name the current flowing through this 6 ohms here, okay, as let's say I1, okay, and then I name the current flowing through the 3 ohms as what I2, okay. Our main focus here will be to find I1, because I1 will be the same as what IN, right? Because when I1 gets to this junction, it will not flow through the 9 ohms. So that means that this is the same current that will flow through this branch. So you're going to say that I1 will be the same as what IN, right? So our main goal here will be to find I1, which is the same as IN. So in redrawing the circuit, you're going to have something like this. You have the current source here, which is the 24 amperes current source, okay, and then you have the 3 ohms here, okay, this is the 3 ohms, and then you have 6 ohms here, you have 6 ohms here, okay. Oh, let me redraw this again. Okay, so this is the 6 ohms, right? And then we know the current flowing through it is I1, which is the same as what IN, right? So if you're able to find I1, you've already found IN. So let's look at how you're going to find I1. So you can find I1 using the current division rule, right? So we're going to have I1 to be equal to 24, okay, times 3 over 3 plus 6. Okay, so let's look at what you're going to get. So 24, okay, times 3 over 9 will give us a value of what? 8 amperes. So we have I to be equal to 8 amperes, which is the same as what? IN, right? So you can see that therefore Norton's current in this circuit will be equal to 8 amperes. Okay, so now let's find Norton's resistance. Okay, so to find Norton's resistance, what you do is that you have to open circuit the current source. Okay, we are going to open circuit the current source. So let's look at how we are going to do that. So I will redraw my circuit. Okay, so we have a current source here. Okay, and then we have a 3 ohms resistor here, then we have 6 ohms here. This is 6 ohms, and then we have 9 ohms here. Okay, and then we want to find Norton's resistance, right, which will be the resistance at these two terminals, that's A and B. Okay, so how do we find Norton's resistance? Okay, so you have to remember that if you want to find Norton's resistance, if there is a voltage source, you have to short circuit the voltage source, and then if there is a current source, you have to open circuit the current source. So we have a current source here, so you have to open circuit it. So you're going to have something like this. Okay, so now let's go ahead and then find Norton's resistance. So in finding Norton's resistance, you see that the 6 ohms here, okay, and then these 3 ohms are going to be in series, right? So we can add the two, and then that give us 9, right? So then we are going to have Rn to equal to 9 times 9, okay, divided by 9 plus 9. So let's count what we are going to get. So we're going to have 9 times 9 divided by 9 plus 9, and then that will give us a value of 9 over 2, okay, which is the same as 4.5 ohms. That's the value for Norton's resistance. Now you can draw Norton's equivalent circuit. So let's look at that. So for Norton's equivalent circuit, Norton's resistance, okay, will be in a parallel connection with the 10 ohms resistor, okay. So let's take this to be the 10 ohms resistor, and then this is the 4.5 ohms resistance, so which is the Norton's resistance, right? And then we have Norton's current here, which we got to be 8 amperes, right? So this is our 8 amperes. Now we can use current division rule, okay, to find the current flowing through the 10 ohms resistor. So let's name that current as I3. So we're going to have I3 to be equal to 8, okay, multiplying 4.5 divided by 4.5 plus 10, right? So let's see what you are going to get for the current going to the 10 ohms resistor. So you have 8 multiplying 4.5 divided by 4.5 plus 10. That gives us a value of 2.483 amperes. So this will be the current flowing through the 10 ohms resistor.